Hello friends, I am Harshal Varade, Assistant Professor from Sanjini College of Engineering, Koparga. Welcome to my new lecture on Unit 6, Introduction to Advanced Materials. Today's topic is advantages over metallic materials and limitations of composite materials, processing and manufacturing of composite materials and composite applications. So what are the advantages of composite materials? Composite materials which are there, they are widely used in engineering applications. So due to their various advantages, first of all, composite materials are light in weight and lower in density. Composites are having high creep resistance. Composite materials have high strength to weight ratio and stiffness to weight ratio are greater than steel or aluminium. Fatigue properties are better than common engineering materials as compared to composites. Composites cannot corrode like steel. Ease of fabrication of large complex structural shapes or modules, that is modular construction, is available with composite materials. Ability to incorporate sensors in material to monitor and correct its performance, such as smart composites. High resistance to impact damage is also one advantageous feature of composite. Improved corrosion resistance is also another feature of composite materials. Along with advantages, there are some disadvantages or limitations of composite materials. Composite materials are having high cost of raw materials and fabrication. Composites are more brittle than the wrought metals and thus they are more easily damaged. The transfer properties may be weak in case of composites. Matrix is weak, therefore low toughness is there with composite materials. Composite materials can be there is difficulty in reusing and disposal of composite materials. Difficult to attach the composite materials, and composite materials which are there, they are having difficulty with analysis. Cost can fluctuate in case of composite materials. Let us learn now the processing or manufacture part of the composite materials. How the composite materials can be processed or manufactured. Let us learn here. Composites consist of two distinct materials which together improve the product performance and lower production cost. Composite materials typically include plated, clad, or coated metals. However, the term composites has involved a material containing matrix or base substance and a reinforcing material. The matrix acts as a binder for the reinforcement while controlling the physical shape and the dimensions of the part. Its primary purpose, however, is to transfer the loads or stress applied to the part to the reinforcement. The matrix also protects the reinforcement from adverse environmental effects. The reinforcement's function is to enhance the mechanical properties of composite and it is typically the main load bearing element. The reinforcements are usually in the form of either fibers or particles. Matrix and the reinforcement materials can be polymers, metals, ceramics or carbon. The most widely used composite materials are fiber reinforced thermosetting polymers. A composite can be defined as a combination of two or more materials that retain their macrostructure, resulting in a material that can be designed to have improved properties than the constituents alone. Advanced composite materials have been used to fabricate many structural parts in engineering applications. This is due to their many attractive characteristics such as lightweight, high strength, high stiffness, good fatigue resistance and good corrosion resistance. Also, the ability to manufacture parts with complicated geometry using fewer components enables manufacturers to save the cost as compared with the same parts made of conventional metallic materials. So, let us learn what are the different stages in the manufacturing of composites. Stage A. In this stage or at this stage, the materials appear in raw basic form. For fibers, these consist of fiber either in the form of filaments or fiber bundles. Fibers may be woven into fabric or braided into braided form. For matrix, the material usually appears in liquid form for the thermoset resin or in granular form in case of thermoplastics. So figure shows the matrix liquid as well as the fiber bundle also. Fiber bundle may be available in the form of bundle, filaments or fabric. Stage B. At this stage, the fibers and the matrix may be combined into a single layer. For the case of thermoset matrix composite, the matrix may appear in a semi-liquid, semi-solid form so that the sheet can hold its shape. For case of thermoplastic composite, the matrix is solidified. This form for thermoset matrix composite is called pre-peg. For the thermoplastic composites, it is called as toe-preg. Stage C. At this stage, the layers in the stage B are stacked on top of each other to make the flat plate laminates. The figure shows this process, that is matrix. Matrix is binded with reinforcing fibers and they form the transformation level 2, that is laminate. This intermediate step is important for the analysis where the material properties are tested or calculated. However, this step is usually bypassed in the manufacturing process of practical composite parts. And step or stage D. This is the final stage where the final product or configuration is formed. So there are various techniques of manufacturing composite materials. First technique is hand layup technique. Second technique is pressure bag and vacuum bag technique. Third technique is pultrusion technique. Fourth technique is resin transfer molding technique. And fifth technique is injection molding techniques. So by making use of various such techniques, various composite materials can be manufactured. Thank you.